Hello, everyone. Um, this is just kind of late Saturday night, just kind of playing. Um, on this server, it's EternaMC. You can see the website on there, actually. Zeflon just got off recently, and he knows that I'm recording right now. Actually, they asked me to record, or somebody mentioned to him, I think, that they wanted someone to, I don't know. Anyway, I was actually just saying that I wanted to record something anyway, and kind of just talk to my subscribers, just because I'm building right now, and I feel like talking a little bit, and I'm just doing something repetitive. So, yep. Anyway, how is my life right now? I'm actually only in 2 classes right now, and I guess relatively speaking, they're not easy classes, but I'm kind of used to not easy classes anymore anyway, so one of them's called graph theory, the other one's called numerical analysis, and yeah, that second class is covering a lot of material very, very quickly, and it doesn't really capture my interest very much, so yeah, it's kind of hard to stay very focused on it. The topics are kind of useful, but it's very kind of abstract and you're just kind of going through it really quickly, so anyway, this is a server that my friend found, and it looks like I just finished this section of the roof, and he this is a little village down here that he I'll just show you right here. He started, so here we go. Iridia is what it's called. And then I just decided that I was going to go and just build an ellipse kind of around the village. And I asked him for permission, and he wanted a village that looks kind of natural, so this is kind of different, but yes, I make myself type ellipse to get up here, and it's good practice for spelling. So anyway, my goal right now is just to finish this roof, I guess. We'll just say I'm done when I get it up to here. It'll be more than halfway done with the whole thing, so if I can get the roof here, we'll be about halfway done. So yeah, not really anything exciting going on, just me talking and building. That's about it. My subscriber count is about 700 right now, and it's interesting because I'm not sure exactly how YouTube is going to play a part in my future, especially like I expect to make videos and stuff, but as far as like how big of a deal that will be, I don't really know. It might just be a simple, you know, just post videos here and there, and that's just how it is. But I've never actually done, other than calculator programming videos, I've never done a development series, and I've never really done much of a critiquing series. And I feel like there is something that I want to do when it comes to like development and programming, and it's not that I'm like, I do like small projects a lot, and usually when you do small projects, you gotta have something that's easy and useful to just put together. And when I say that, I think of Python. I think of this programming language that, in one sense, seems really practical, really easy to kind of get things working, but in another sense, to me, it's kind of a, I don't know how to explain it. It's kind of a language. It's not really. It's a more of like a tool. It's almost like a scripting type tool. So it's something that interfaces very well with like the system. Whereas a programming language like C, and I don't want to get into this too much, but I think C is something that we have to be careful not to, that societies can expand on a lot, but it can only do so much before we add too much, essentially like junk to what should be a simple formal language. And I'll get into this later, but it has a lot to do with like theory and stuff, and how languages themselves, like programming languages, or like the actual like formal definition of a language, like the mathematical definition of a language, how they essentially will converge, not just really in the future, but in the sense of abstraction. Like if you want to represent something very abstract, languages will will have to have a certain pattern. And what I mean by that is they will have to simplify things that in the right way, in the best possible, in the optimum possible way, essentially. They'll have to simplify things not for like computational speed necessarily. I mean, it relates to that, but essentially, when you really abstract away a problem, you're dealing with just kind of in general, you're dealing with time and space. And yes, you are kind of dealing with a specific type of hardware, practically speaking. But ultimately what it comes down to is time and space, and then the growth rates of those things. And when you make a language that you're going to use to define what's going on with a computer, you're really like balancing this kind of idea of making something practical for here and now, and making something that's like more abstract or more eternal or long lasting. And I feel like C is kind of in the, when people add to it, they're just making it kind of more practical here and now type thing, when really C is kind of just an abstraction from, it's basically a level, like a level up from assembly, and then you have higher programming languages, and at some point you get to this point where essentially what defines one of these really good abstract, super abstract languages is how good they are at being a language, and that's it. Not how good they are with modern day computers and stuff like that, and what, little tricks that'll help you, but in the growth rate, you're always looking at like the main problem that you're trying to solve, the main issue. And there's a lot of like graphs and stuff. Imagine like every issue, every dimension you can think of this. There's some kind of graph representing like, so it's an x squared graph, or it's a e to the x graph, or something like that. There's some kind of growth rate. And in the case that I'm talking about is in a really abstract system. Like if you have a really, like for example, Minecraft. I'm going to bring Minecraft into this. If you look at the classes for Minecraft in Java, there are a lot of them. It is actually a really complicated set of classes, and that's how real software is. Real software has very, very complicated systems, very abstract sets of classes and objects and things like that. And obviously just C by itself can't really handle it. C++, now you have objects and you have things that can be organized, and the way it's organized is through something that actually is a spawn from graph theory. Whether or not even the people who designed it realize it or not, graph theory is essentially, graphs are essentially the way to represent the model of object-oriented classes. That you just have these, you have these classes, and you have the relationships between the classes, which are going to be inheritances and usages and dependencies. And this also includes libraries and, like, for example, file dependencies. That kind of relates in. Now files, if something's written according to a file, to me that is still a machine abstraction. That's a system abstraction. So it's not, I'm not saying it's like definitely a bad thing. Like, I'm not saying, hey, if you're a C# developer, if you're using C++ or C#, like, stop what you're doing or whatever. No, I'm not saying that. Everyone plays their different role in society, and it kind of fits according to, like, I would assume it sits according to some, like, Zipf's law or something when it comes to looking at, like, hey, maybe the abstraction. So me in particular, I am interested in, like, the futures of these things. I'm interested in, like, where things are converging, where things are headed, how to perfect things, like, kind of the ideal. So so we have these kind of old school languages, and we have some quotes from some guys that say, like, hey, you know, and it looks like we're done, actually. And me just talking, wow. I didn't realize that I felt like I just started talking. But anyway, I'm talking about these crazy topics. But it's just an example of stuff that I kind of think about nowadays, and I have some projects that I'm working on, and how they're actually going to play out, I'm not sure. It's hard for me to kind of keep to figure things out the right way, but essentially what I'm trying to work on is well, there's a few things that it relates to. There's some core things, and then there's some kind of side things. So the core things is basically this is spawned from education. So basically, rewind back to 2011. I liked programming kind of simply. I didn't know all the theory, but I kind of wanted people to learn it because it seemed kind of simple, and you could solve tasks with it. So I came up with a system for editing parse trees, and that's what Inspiration Basic was. You can check my videos on it. You can essentially program without having to Google anything and without having to know the language that you're working with. You essentially just use menus, and you can do silly things like make a sorting algorithm or an algorithm that just prints out prime numbers, and that's exactly what I did. In fact, I completed an iPhone project, an application, and I posted it on the App Store, and it was available for download. And I had YouTube videos about it and everything. And in a way, that app was kind of it was awesome because it was something that I was working on for a long time. But in another way, it's kind of silly app. It's kind of pointless, kind of useless, and it's not even good enough for someone to really learn from. And I'm not, and that doesn't get me down or anything. It's just that's not where I want to stop. That's not where I want to end. Because obviously that in and of itself is not very useful. I want to make something actually useful. And I didn't have this goal initially, but after I learned some computer science theory and some things from school, I realized they're actually, wow, I had exactly, that was funny. Anyway, after I learned some computer science theory, I realized that I was actually onto something bigger. I had a feeling at first, but I wanted to know, okay, is this actually true, or am I just like, is this just a feeling? But I realized that it is actually true, that what I was actually coming up with was applicable, and not only applicable, but I actually have a statement which, to me, is enough to convince me that it's necessary for future development. So, and what that is taking the idea that I had, where you don't need to Google anything, you don't need to know the language you're working with, but deeper than that, there's growth rates with what you're working with. So imagine you're coding something, or even if you're a mathematician, imagine you're writing a proof, and you're using these axioms, or you're coding and you're using these libraries, and you're using these different types and just different things, okay? Whatever you're using, even if it's just syntax rules, you're using something to construct this program. It might be easy at the base level to do it, but let's say you have like millions of lines of code. Let's say you have a really complicated project, and this is not something that I'm used to working with. It's just something that I know exists. I'm not that used to working with it, but I know how. I have kind of an understanding for things, for certain things, even if I haven't like first-handedly gone through them all, because I have programmed for pretty much my whole life, so I do have I have thought about these types of things. But imagine not only that you have a huge program, and not only and it's object oriented, like you have these things that help you abstract it. But let's say even though it's object oriented, it's still huge and it's still complex. And actually it's so complex that you're looking to make another class, and you're not even sure if there's a few things about this class that go through your mind that actually will take a lot of time. For example, like, will this class has to use an object which uses, like, I don't know, another tree of classes that it's related to. And then it has to use another tree of classes, and then there's some relationship between the two trees of classes, and you have to consider, like, okay, am I making anything new that I don't already have? Is this all going to be compatible? Does this make sense? Is it possible for me to, like, move this group of like 5 classes and merge them underneath a new class where I'm separating I don't know, into a different category. Essentially it's category theory, and it essentially turns into a mess. And if you're looking at from that level, there's a lot of tactics involved. There's a lot of things that people think this is how we should develop in the future, and those are called design patterns. And design patterns are cool, like they're interesting things, and they're and this isn't like a hard theory, this isn't like a hard proof or anything, but my thoughts on it is that those will only go so far until they themselves get so complex, and then you have to rely on something more abstract. You have to rely on something like category theory, rather than just simple graph theory and then applying all these rules. For example, I don't know, like in C# you can have like relationships between like class lists of different types of objects, but you can't have a list. You can't have a pointer to an animal list that's actually the object is like let's say an elephant list, and then expect to try to add to it. Even though it's an animal list, you can't just add a giraffe to it because it's actually an elephant list. So there's this relationship that's there that's not enforced by the compilation, but it's enforced by it's enforced by what you're allowed to define in input and outputs in the class structures in the first place. So C# will force you to define the classes in such a way that they know that provably it would work. Haskell's a little different. They'll actually it'll inference through your entire code, and it will only compile if everything does work. So it doesn't just check the relationship between two classes, but it checks recursively to see if all of the types actually properly match up. So this is really like confusing stuff. I'm not even good at I'm not even like processing the actual thing going on. I just kind of know generally what's going on, and the idea is that I'm trying to convey to people, or that I want to use, is the fact that there's certain growth rates in there that the user has to deal with, and we'll have to deal with more so and more so until essentially there's going to be a growth. So organizing all these things is one way to go about it, but it will get more and more complex. Using functional programming, like a language like F#, it introduces this category theory concept into your complex program, but there's two issues with this, okay? So there's two. One of them is when you're compiling, you have to compile all your programs, the whole list of them, every time. It takes forever, and you can't do that with really large systems of programming. So you can't do it according to file bases. You actually you'd have to have a system that compiles separate files. And this isn't something that I thought of. I thought of the solution before I thought of this problem. I realized that my solution solved this problem. I didn't think, oh, how do I solve this problem? Oh, this is the solution. No, I thought of the solution first, and then I realized, hey, this also solves this problem. The second problem that I realized that my solution solves is that of getting types to match up. So it takes forever for a user, if they look at a type. Imagine a big, if you've programmed in something with like with functional types, and you know that you can have a type that is huge, like a function that takes an int, that takes a function that takes a string, that takes a function that takes a blah arg foo, that returns a foo, that returns an int, that takes a function, blah 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 blah, and it's like 30 characters long. And then you have that in 5 different sections of your code where they're not matching up, and you don't know which one needs to be edited, which one needs to be changed. That's a problem, and I've seen this one. This is the one that I've seen firsthand, and I realized that there's definitely a way around this, but it changes the way we program completely. Like, it turns it upside down. Well, okay, not upside down, but essentially we cannot program using just regular text anymore. We actually have to program by constructing parse trees, and only by doing that. And when we do that, there's a couple of things that happens at this point. You're combining the compiler with the editor, with the interpreter, all into one tool, instead of having them separate processes. You can no longer just like run one and then the other on the entire program. You actually have to run on expressions at a time. So they're kind of separate functions, but they're all used like at the same time to help each other. And actually the compiler and the interpreter kind of turn out to be very similar. In fact, they're essentially the same thing, except that a compiler is doing something that's non-deterministic, and an interpreter is doing something that's deterministic. And by what I mean by that is, if you look at your code for like, I don't know, an ML language or something, a language that's very simple and abstract, you'll notice that there's not much difference between type expressions, like something that defines what a type is, and an actual expression that tells the computer what computations to do or to evaluate when the program is running. So for types, you have these ORs, and something like a list A could be empty, or it could have something in it, for example. Or any types you come up with, there's a list of things that are possible, and it's non-deterministic. You don't know which one, when you're looking at that, which one, it doesn't really matter which one. It's only there to verify whether a program is correct or not. You're not there to execute it. So it just is there. And you don't have to do anything with all the permutations. You just have to know it's there, and then the compiler uses it. When you interpret, you're basically doing the same thing, except there's only one choice. And so you just run it. So that's kind of one idea that goes hand in hand with this. So what I'm trying to make, and I might show you, I don't know, I already have YouTube videos about it, and they're available and people can watch them, but just imagine this for me. Imagine being able to create a very, very, very extremely complex software project. Like, so complex, it has gigabytes and gigabytes of code, of source code. It's just huge. Just imagine something unbelievably humongous. But when you go to edit something or change something, it doesn't take a very long time to get it to where it's compiled. I'm not going to say it doesn't take forever to compile the whole thing. I'm just going to say, if you want to change something, imagine it not taking very long at all to get your compiled output. And secondly, imagine that it's easy. Even though it's a very complex project, imagine that it's actually as easy to manage that project at that crazy abstract level as it is to edit code at like a low level. Just imagine like regular functional code, how easy that is. Now imagine something with like huge trees of types, really complicated types that would take forever for a normal person to try to like combine. And imagine somehow magically, I'll just say magically, even though it's not magic, I'm just saying so that you can imagine it. Just imagine that it's really easy to work with them. You only need 7 things. The human brain only holds about 7 things in your head at a time. So whatever the system is, whatever it does, it only requires that you have 7 things in your head at a time to deal with, even though it's really abstract. So anyway, that's just a thought. That's just the programming side. If you know about the Curry-Howard isomorphism, this basically also would be similar to constructing proofs. Now, people already do this. The research for the languages and the math behind what I'm saying is there for what these things are. For the actual tools, for the actual things to make it applicable to people, I don't see these is there. I see really, when I see a tool like an editing tool, and this goes with operating systems too. When I see an operating system, when I see an editor, when I see people doing math, I do not see them using the actual top research that's out there. I do not see it being done. I don't see big companies doing it. I don't see anyone doing it. I just see that the research is there, the knowledge is there, and people don't realize, it's almost like people don't realize what's actually going on. And I think what's actually going on is Zipf's law. You have really high research. Zipf's law, by the way, I'll just pretend I'm plotting it right here. So it starts off, so it's really tall here. Watch the Vsauce video on Zipf's law. This is really cool. So it goes kind of like that. So this is the x-axis. Goes like that. So it basically says the second most used word in a book or in language is used half as much as the most used word, and then the third is used about 1/3 as much, and the fourth is used about 1/4 as much, and so on and so forth, and you get kind of this distribution. And so this distribution applies to way more than just words. It applies to like how your brain works. It applies to like the floor usage of your carpet in your house. It applies to like everything you can imagine, like the width of moons in space. This applies to like everything in nature. And one of the things I'm sure it applies to is the way we kind of economics. It already applies, but I'm thinking it also applies to like our research and our understanding of and our abstraction of computer languages. So you got all these people down here using, you know, just normal programming language things, Python, C++, blah, 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 whatever you have you. And then up here you got like these nerds at like Princeton University, you know, working with some crazy, you know, Agda or who knows. And it's just this distribution that kind of whoop, you know. Now, if you want to make our world higher technology, okay, first of all, we have to accept that Zipf's law just exists. We can't change it. It's just there. So it's always going to be like this, kind of, if we're looking at a particular problem, that problem, like Zipf's law will still apply to things, but fundamental problems could change. Like it doesn't mean that things can't, you know, reach a new type of equilibrium. But what I'm saying is, assuming that Zipf's law will hold again, how would we double our technology? Well, a lot of people or actually not a lot of people, very few people, but at least some people go and research this, and very few people actually go ahead and try to research something, and they're like, okay, well, we'll help out. I'm gonna go and study at Princeton and blah 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 blah, do this research and try to increase it, which is great. It's fine. What's gonna happen is, if they try to double that, well, essentially university is going to be like, what are you trying to do? You're spending too much. It's too much money. We can't do that. And it's going to be brought back down. So they're not really going to change the distribution a lot. Now, if you want to change the distribution, you have to change it by its integral, not by just like adding at one point. So how do you do that? Well, that's what mass production is. That's what, when you create a computer and you sell it to everyone on the planet, now suddenly everyone's height doubled, and now you just doubled the area of this thing, and now if it's Zipf's law again, it's got to redistribute, and now it's going to go up to the left side. Sorry, I'm looking over there because I heard something. It's going to go up, and it's going to double this, whatever the peak was. So my idea is, and it's not just business, because I have to do research on how to actually get this to work. This is like a researchy thing. It's not just like it's not like, oh, I'm just going to do business, So what we have to do, what I want to do, is I want to take this research and all this cool stuff that's been figured out, and I just have to figure out a few more kinks, a few more things, and put everything together, and it all kind of works like one beautiful kind of, I don't know, orchestra or something, and that's just a part of it. But if we recreate this tool that solves these growth rate problems, we can distribute that to everyone else who's developing, and they will realize, maybe one at a time, but eventually they'll just kind of, boom, they'll just overcome it. Like, it'll be an exponential thing when it actually happens. And people will realize, like, whoa. Just like object-oriented programming, like, there will be a thing where people just kind of, voop. I'm assuming this would happen. And they'll just realize, like, hey, this actually makes more sense. And now I haven't been playing. So, anyway, EternaMC. My idea is that I want to do that. I want to create a tool that people are going to use, or that that'll help people realize how to abstract their code, so they can make huge software projects on their little PCs at home. Just humongous things that you think only a business would do. I want people to be able to do that on their own home computer, and their own little, even on their phone or something like that. Something really complicated that you wouldn't even imagine. You could. I'm imagining you could actually do something that crazy, that complicated, on a little laptop. And the reason is because I don't think we have to compile things the way that people have compiled them in the past, and I think I have solid reasoning for this. The more and more I thought about it, the more and more I realized the difference between machine abstractions and language abstractions. And this very wise man, I can't remember the quote, I'm sorry I don't have it for you right now, maybe someone can post it or something in the comments, but somebody actually said, imperative programming will be chiseled away, and eventually somebody will come down and they'll hit the granite of functional programming. And that's a very deep thing to say. But there's a reason behind it, and it's actually the mathematics. It's actually the purity of the mathematics, and And actually, the way he put it was even smarter, because it's not even just you're chiseling it away. It's you're exercising it. You're beating the bush until you realize that everything you've been doing would be smarter if you're doing it. Everything you've been doing is just repeating this pattern, these patterns that actually are, in and of themselves, they're going to end up being functional program. They're going to be category theoretical things when you combine them all together. So it sounds crazy. It sounds like what? Like, but the point is, there's a way to organize things very well, and you don't always have to follow those rules precisely. But if you create a system that just builds things according to those rules in the first place, it's different. Like, and that's how it is. That's how it's always been with programs in general. I mean, back in the day, we had go-tos and stuff, right? We had like jumps and go-tos and all this other stuff, and people thought like, oh yeah, let's do that because we're free to do, whatever. It's a mission. We're telling the machine what to do. But eventually, what happened? Well, we got rid of the go-tos because we realized, hey, no matter what you want to do with the go-to, no matter what it is, it's handled with the while loop and the if statement and the function calling itself recursively. It's handled by all those things just fine. There's nothing a go-to can do that you can't handle just as fine of a time without it. And that's the same with functional programming and with object-oriented and stuff. We have all this object-oriented stuff, but eventually, in my mind, it's going to turn into the next go-to. It's going to be the next thing that people are going to realize, like, oh, I get it now. But it's a really abstract thing, so it's actually not many people actually will like understand it yet. But I don't think it's because anyone's dumb. I don't think it's because people are just, they don't have the intelligence or anything. It's just that we're not at that level yet. I mean, people didn't have computers back when, a couple hundred years ago. They didn't even think about the things I'm talking about. So we're still progressing. We're still moving somewhere. And we got brilliant people. We got really intelligent people, but they just don't see this particular thing yet. And what I see is if they have the tool, that's all it takes. It's just having the right tool. And having a tool that makes it so obvious, something that you can use. And there's a few things of usability that go with the tool. One of them that I think we should stick with is you should never have to Google something. It should be self-documenting, and that's what happens when you have a menu like this that's deterministic. Is actually you don't have to Google something, because that's kind of the way it works. Is that you I mean, you could try to make it deterministic, but you still have to memorize something. But to me, like that, there's no point. Like, if you're gonna make something deterministic, which means you have a finite number of choices in your menus, not a very broad number of choices. You can't just type in text. Then you might as well just make it all built into the same system. And I've even I had a friend at school. He showed me a really cool project that he made. It was like this. It was a space shooter game, and I really liked it. And I was like, hey, I had this idea, and he would actually have to make a shader. We talked about this a little bit to make this work, but I was like, hey, I have this idea where instead of you just being in the middle and seeing what's around you, and then maybe having like a mini map, why don't we combine the ideas of like a mini map with the space around you and use like a fractal type thing, where it's not a fractal, it's more of a stretch thing, but it's similar to some fractals look like this, where you're in the middle, things close to you look normal, but the closer you get to the edge, the more squashed it is, to the point where, like, if you're at the edge, it's like essentially infinite distance from you. And so that way you can see, so it acts as both as a map and as like your game. and that would be cool. I think if somebody made a game that looked like that, that would be cool. And I even have the function for it. I'll even tell you it's the formula. If you have, like, let's say 1 minus 1 over x, 1 over 2 to the x, that's one function. But you can change 1 over 2 to any number that's between 0 and 1. And anyway, point is, ask me in the comments if you want to know. Point is, I was combining these two ideas together because I knew that they both kind of naturally could be combined. And that goes with a lot of things. There's a lot of connections and things nowadays, and it's good to understand these connections, these ideal connections, not like practical like connections, but like ideal, kind of why two things are similar, why two things have the same shape, have the same pattern, but they're not the same thing. Well, sometimes we should take those things and we should make them the same thing. Sometimes it's smarter to make them the same thing. And we just don't realize it. And so, anyway, I believe there's guidance. I believe that there's like a path we can take for programming languages in theory, in computer science. And I don't know how many people think of it that way, but I don't think it's very many. And I think that there are people thinking about it, but if we want to advance this, if we want to push this forward, we have to make the right tools that allow people to learn this and to realize how things work and to realize what's better, what's worse. Because then when they realize it, then we'll advance again. We'll come up with even more brilliant things that I haven't even thought of. I don't know if you can get much, better than like category theory. I don't know, but there's certain things that still kind of are pretty amazing. Like, I don't know, other theories of computation, models of computation, like cellular automata. Like, how do we match that up with? There's no close isomorphism that I know of between cellular automata and complexity from that with like language models like lambda calculus or Turing machines. We've proven them to be equivalent, but they're not very, from what I understand, they don't interact with, they're not proofs that keep the cellular automata simple anymore. So I'm just curious, like, I wonder if we could take an advantage of the simplicity of those models. I mean, in neural nets, we kind of maybe are. I'm not sure, because it's like a local system where things are interacting at a very local level. But as far as like computation-wise, other than that, I'm not really sure. It might just be that like that's the nature of it. And so I mean, point is, I think there's other things that we have to figure out. There's other things we have to to generalize math, but we basically are, and it's good to do that. It's good to generalize and to kind of wrap everything up together in a more general theory. And the stuff coming out of Princeton, I mean, it's good. Homotopy type theory is pretty awesome. They combined homotopy theory and type theory together and realized they were the same thing pretty much. And then they also realized that using types, using construction, like intuitionistic logic, which is a specific logic system that's a subset of classical logic, well, okay, I think it's a subset of classical logic. Anyway, they're using that to reconstruct our models of mathematics, to reconstruct how we do what we work on, the reals, calculus, all this other stuff. They're reconstructing it with this, which is a lot cleaner. It's a lot nicer to work with. So, yeah, as far as my channel goes, I'm not sure what small projects I'm going to do here and there. I might try to do some Python projects. I did make an unscrambler to kind of, cheat on a server, quote unquote, because they had this game that basically asks you to unscramble words. And so, yeah, I made a project like that, and I could show it to you, and it's in Python, and but the thing is, I haven't really made many games. I haven't made like that many, games in Java and Python and stuff. I did make a Java um, application that solves 2048, the game, but I mean, it's not that impressive. It would make for a nice YouTube video, maybe, but um, the thing that I'm wondering if anyone's followed this video along so far. So this is very special now, just for you. If you've listened to me this entire time, I want to ask you, please tell me, please comment for me and tell me whether or not you think that I should share the development process for the project that I'm working on, because it's a very serious project. I'm very serious about it. I'm willing to put time and money and all whatever to get this thing actually created and working. But it's also serious to me as to whether I should share it and whether I should make it public, kind of show people the process that I'm going through when I'm developing it, or maybe I should just record it and kind of keep it archived or something. I don't know. But please tell me what you think about that. Tell me what you think, because I mean, I don't know if it's something that I could end up selling, or it's something that I should just kind of make open source, and who knows. I mean, I do need to survive. I need money and all that stuff, and I kind of wish I want a family, but let me know what you think I should do as far as that project, as far as making this tool. So anyway, thanks for listening. I know that was very technical, and it was just kind of things that were on my mind, and I always have lots of things on my mind. I'm usually thinking about something or another. I think about things that are deeper and things that maybe not so deep, but yeah. Please let me know what you think about that, and thank you for your time. Thanks for listening to me rant and talking about all this. And if you didn't understand it but listened anyway, I'm sorry. Thanks for listening anyway. You can just let me know what you really want out of this channel, because really there's not a lot of subscribers right now, so compared to what there could be. So if somebody just asks for something, more likely now is when they'll be able to convince me to do it. If I had too many subscribers, if I had like 100 times what I have now, who knows? If I had 1,000 times what I had now, who knows? That would be possible. But right now, if you ask for something, I could probably consider it. If it's a Python project or something simple, or a series or something like that, now's probably a good time to let me know what it is that you want to see. But anyway, that's just my thoughts for you. This has been Tim, and I am checking out. I will see you later.